In this video, we learn about the antiderivative and the indefinite integral. Now, the antiderivative is actually a really simple concept to be explained. Given a function little f, now we would like to find a different function which has little f as its derivative. So we answer the following question. Which function f of x satisfies capital F prime of x equals little f of x? So it is kind of the inverse process of differentiation. Instead of differentiating little f, now we want to find another function, capital F, so that capital F prime is little f. And we are pretty good in differentiation already, so in many cases we can just guess what the antiderivative would be. So for example, let's take f of x is x squared. So which function would have derivative to be x squared? Well, after thinking just a little bit, we know it must be of the form x to the 3. But then if we differentiate x to the 3, we get 3 times x squared. So the factor 3 is in the way, and we make up for it by a 1/3 in front. Okay, so if I differentiate 1/3 x to the 3, then I get x squared. So let's call this capital F. Okay, then capital F prime of x is equal to x squared, which is the original function. We would say f of x equals 1/3 x to the 3 is an antiderivative of f of x is equal to x squared. Okay, so that's all. But not quite. So there's a little subtlety which goes like follows. So let's look at another function. Let's call it g of x. And let's do the 1/3 x to the 3, but maybe subtract 5. So that's a different function than f, but let's look at the derivative. So then g prime is of course x squared, and then minus 5. If I differentiate a constant, I get 0. So the derivative is also x squared. Okay? So then f of x. So then this means g of x is also an antiderivative of f of x is equal to x squared. Aha! So this concept of an antiderivative is not unique. You can in fact add a constant or subtract a constant, and you still get an antiderivative. So in general, we will write f of x equals 1/3 x to the 3 plus a constant c. And this is a standard way to write down the antiderivative. So we find a function which differentiates to be little f, but then we always have to add a constant c or subtract a constant c like we subtracted 5 here. So then c is minus 5. Okay, so here's the definition. A function f is called antiderivative of little f if f prime is f. As simple as that. So here I show you a few antiderivatives for our known functions. So we had this one, right, x squared. So the general antiderivative is 1/3 x cubed plus a constant. If I go to x, so here the next one, then I have 1/2 x squared plus a constant. If I do x to the 3, I have 1/4 x to the 4 plus a constant. Okay, and so you can, using the power rule, you can go up and down this list and find for all power functions, you can find the antiderivative. But oops, so here we left question marks by x to the minus 1. But I'm sure many of you know anyways what it is. It's a logarithm, right? It's a natural logarithm. So here, this is ln x plus a constant. And strangely enough, to finding this first bit of the antiderivative is rather easy, and students do really well. But many students forget this constant. So never, ever forget the constant if it comes down to compute an antiderivative. Okay? Let's do this for a trigonometric function. So let's start with maybe a cosine x. So f of x is cosine x. Which function would satisfy f prime is cosine? Well, we know if we differentiate sine, we get cosine, right? So then this would be sine x. Cool. But then don't forget c plus c. So the antiderivative of cosine is sine x plus c. And then here in the table I show you the other ones. So the antiderivative of minus sine is cosine plus c, or the antiderivative of minus cosecant square is cotangent plus c. Now, this is all very nice, but we also would like to have a nice symbol to work with. So we would like to introduce a symbol which symbolizes to do the antiderivative. And this symbol is the integral sign. So here it is. So if capital F prime equals little f, then we write integral f of x dx is capital F plus c. So this integral sign, and then putting in the function, and then dx, all this together denotes the general antiderivative of little f. So the integral sign is kind of the dual object to the sign d by dx. Okay, so the one goes in the one direction, the other goes in the opposite direction. So this is the indefinite integral. Now, many of you know the integral related to area under a curve or something, or a Riemann sum. It's the same symbol, and indeed it has to do with the area under the curve, but we will learn this much later in some other videos. So let's do some antiderivatives here. So the antiderivative of x to the 3 dx, or you could say the indefinite integral x to the 3 dx, is what? So we need to find the antiderivative of x to the 3, which is a quarter x to the 4, and then we always add a constant. We can do more complicated things like the integral of t plus 5 divided by t to the 3/2 dt. Now the integration variable is t, right? So this dt kind of indicates what the integration variable is called here. So we have a function of t. We write this as an integral of t divided by t to the 3/2 plus 5 divided by t to the 3/2 dt. And then this is integral. So we get t to the 1 minus 3/2 is 2/2 minus 3/2 is minus 1/2 plus 5 t to the minus 3/2 dt. Now for each of these terms, for example t to the minus 1/2, I can find the antiderivative. It is t to the 1/2, but then with the right factor in front. So the factor would be a 2. So then this equals 2 t to the 1/2 plus, then keep the 5, t to the minus 3/2. The antiderivative is then t to the minus 1/2. And so we get a minus 2 in front, minus 2, t to the minus 1/2. And then always the constant c. Now, if this was a bit quick, stop the video and do it yourself. So maybe take the function 2t to the 1/2 minus 10t to the minus 1/2 and differentiate. And then you will see you get the previous function out of it. And then here a final example, cosine of 2u. If we differentiate sine, we get cosine. So it must be something like sine of 2u. If we differentiate sine of 2u, we get an inner derivative, a factor 2, which we have to make up for. So we get a 1/2 in front plus a constant. Let me summarize. So the antiderivative of f is any function capital F which satisfies f prime is little f. And there can be many. It is not unique. But we distinguish them by a constant c. And a way to write down the general antiderivative of a function is called the indefinite integral. So capital F plus any constant is integral f of x dx. Oh, hi Tolo. What's up? If I like to join the ADM, what is the ADM? The antiderivative movement? Are you serious? No derivatives! No derivatives! Stop derivatives! We are antiderivatives!